All right. Hello, everybody. Time for Belovsky Science. A little bit different today. I'm sorry I'm a little bit later. I was not able to record a lesson at school today because I had a professional development training I had to do during seventh period, and it took up the whole period. So I wasn't able to make a video. Trust me, I'd much rather do it during my planning period than to have to do it after baseball practice here at my house. But anyway, here we are Gonna throw this video together real quick for you so that you'll know exactly what went on today in class. The first part of class, we went over the chapter 2, lesson 2 review, this thing right here. And students turned it in. You were supposed to have it turned in today at 6 o'clock. And when I'm making this video right now, it's 6:12. So you were supposed to have already had it turned in. If you're watching this video and you haven't turned it in, well, you need to make sure you get it turned in so that you can get half credit. Remember, it's going to get docked for being turned in late. All right. Don't forget also to do your warm up. Your warm up will be located right here. And we started chapter 2, section 3. Now, chapter 2, section 3 is mainly a review. We talked a lot about chapter 2, section 3. Let's see if I can get some of that glare off your eye. We talked a lot of this chapter, this section, last week when we were studying about the microscope. And we also went over some of it back in October. If you'll remember, when I was sent home for quarantine because I had been exposed to the virus, and I got sent home for a week. Well, that week when I was teaching you from here at this exact spot, we went over some of the stuff that's in section 2. So let's go over it real quick. It shouldn't take a lot of time. It should be pretty quick. All right. Internet's not as good here, so it's kind of going to be slow. So not like when it is at school when I can do it nice and fast, but when I have to sit in on meetings, you kind of have to make do with what you can. All right. So what you need to do is you need to go to the Google Doc right here. You need to go to this Google Doc. You need to click on that, and then you need to put me on the other half of your screen so that you can hear my voice and see the textbook that I am about to show you here. I've clicked on it. It's just going to take a minute. This is why I'd much rather do the videos at school. All right. Let's scroll down here and let's get to section 3. This is section 2. Still section 2. All right, we're coming up on. All right, here we are. Here's section 3. All right, won't take us very long because we've already covered the majority of this material. All right, so we're going to talk today. We're going to start talking about what the cell is, how we discovered cells, the folks that came up with the cell theory, things like that. That should all ring a bell in your mind. And don't be surprised if we got a test coming up next week as well. Probably this chapter 2 test will probably be sometime early next week. All right. And my cursor keeps disappearing on me. All right. So if you take a look at this picture right here, you're going to see, if I ask you, where was this picture made? Most likely you'd think that it was made in an ocean or a sea somewhere, in a someplace that's got a coral reef or something. Now, this picture right here that you're looking at is actually made in a forest. What you're looking at is a pink coral fungus. And this little guy standing right here next to it is a newt, and he's standing on leaves. Okay, so what they were wanting to get at was that all of these things that you're looking at here are made of cells. And it doesn't matter if you're in a forest, if you're in a desert, if you're in a forest, desert, ocean, wherever. If it's living, then cells are involved. Okay, so on your review sheet, the first word Number 2, I believe, is cell. All right. So the definition for cell is located right here. Now, we've already defined cell once, but this is a little bit more. So what do you need to write down for cell? And let me... Okay, why did it just disappear on me? All right, let's try again here. And it's going to go back to the beginning. All right, so let me go down. I'm sorry. This is why I like to do this at school. All right. So, what is a cell? Okay. Right here is the definition for cell. All right. Cells form the parts of the organism and carry out all of the organism's processes and functions. And it's kind of hard to see that right there. So let's make it so that you can see it. All right, so cells form the parts of an organism and carry out all of the organism's processes or functions. Hit pause and type that in. Okay, so everything about you, everything that's going on inside of your body is taking place because of cells. Cells are doing something. You're looking at me, and the cells in the back of your eye are casting an image that's being interpreted by your brain cells. Every bit of that's done by cells. Your heart's beating. Your heart's made of cells. It's pumping blood. Blood is made of cells through your arteries and veins. Your arteries and veins are made out of cells. When you eat supper, you digest food, and that food goes to your stomach, and your digestive system is made out of cells. Everything about you is made up of cells. I'll take that back. I talked in class. There's 3 things I can think of that on your body that are not, if you looked at it under the microscope, would not be cells. All right. Your fingernails and toenails, your hair, and your teeth. Okay. Those are made up of different substances. All right. And you wouldn't see cells underneath. If your enamel is not made up of cells, your hair is not made of cells, but they are made by cells. Okay. So your cells are parts of organisms, are part of an organism that carry out all the functions that go on within your body. Okay. Now, the next word that you need to write down, if I come over here and open up your Google document, you need to scroll down, and you need to look for number 7, microscope. All right. What is a microscope? All right. Well, if we come down a little bit here, and if you will look right here, you will see microscope. All right. So what do you need to write for microscope? A microscope is an instrument that makes small objects look larger. Okay. Hit pause and we'll talk about it. Okay. A microscope is anything that you may have that can make small objects look larger. A magnifying glass, yes, is a microscope. My glasses have parts of them called bifocals, and they make print bigger so that I can read it. I can see the print bigger. That makes it a microscope as well. Okay. Anything that makes something look bigger, then that is a microscope. All right. Let's move on here. Now, some of this stuff, you've heard it before. All right. Here it talks about Robert Hooke, and we've already talked about how Robert Hooke, he's the one that created the modern day microscope. Here is Robert Hooke in the middle. This is his modern day looking microscope. Some folks misunderstood me for saying that this is that Robert Hooke created the microscope. Robert Hooke created what we call the modern day microscope. Okay. And this microscope has a modern look to it. But he did not create the first microscope. That's over here. And this item that you see over here was created by the Janssen brothers, Zacharias and Hans Janssen, and the late 1500s. And it had two lenses in it. It had a lens in the eyepiece and in the objective lens end, but it was primitive as well. And over here is Leeuwenhoek. You remember Anton van Leeuwenhoek, the dude that would ask people if he could scrape stuff off their teeth and gums? Creepy. This was the microscope that he used right here, and it's primitive as well. You would hold it by the handle, and of course I can't get my cursor to work. You would hold it by the handle, and which is up at the top here, and then you'd look through the eyepiece, which would be right here, and whatever you're looking at would be stuck on the end right here, and you could focus it by moving it back and forth, and a primitive microscope as well. All right. Let's move on. All right, here's where it talked about Leeuwenhoek. Now, these pictures right here, we're starting to get into modern microscopes. The microscope that you see right here was created in 1886. The 1965 scanning electron microscope, down here, is also an electron microscope, 1933. Here you see a tunneling microscope. These microscopes are millions of dollars right here. They're very expensive. So, all right, let's scroll down a little bit more here. Cell theory. Okay, so Schleiden, Schwann, and Foucault. We talked about them. Schleiden is the one that discovered all plants are made of cells. Schwann discovered that all animals are made of cells. And Foucault said, hey, I bet I know where cells come from. Cells come from other cells, because people were like, what creates cells? Where do they come from? And Foucault was like, I bet cells make cells. And he was exactly right. All right. So the three of them together created what is called the cell theory. All right. So what is the cell theory? All right. Right here is the cell theory. And what you need to write is what is located with these three bullet points right here. All living things are composed of cells. Cells are the basic units of structure and function in living things, and all cells are produced from other cells. Hit pause and type that in. Okay, so Schleiden, Schwann, and Foucault, their information helped to create what we call today the cell theory. And the cell theory basically states every living thing is made of cells. Cells carry on the function and make the structure of a being, and cells make cells. Cells just don't come out of nowhere. Cells create themselves. Okay? So, I'm making a mark for no reason. Okay, let's move to the next page here. Okay. Now, the next words is after cell theory, I believe magnification, and I've skipped one. Let's see. Microscope we did. Cell theory we just did. Magnification. All right. So magnification is next. Magnification can be found in this paragraph right here, if I can get the marker to work. Magnification is the ability to make things look larger than they are. All right, hit pause. Okay, so the ability to magnify means you're able to make something bigger than what it actually is, such as my glasses, the bifocal part, a microscope, a magnifying glass. They have the capability of making things look bigger. Okay, now that and without magnification, you do not have a microscope. So in order to do this, you have to have what's called a lens. Okay. So what is a lens? I'm trying to get this to move up. All right. So what is a lens? All right. It's in the next paragraph right here in the bold print. Lens. Okay. Lens and light microscopes magnify an object by bending the light that passes through them. Hit pause and we'll talk about it some more. Okay, so what in the world is, how do lenses work? And lots of people think that it is a very complicated thing that allows a lens to work. It's actually very, very simple. Let's say, have you ever been drinking your water or tea in a restaurant and you stick your straw down in there and you notice that the straw has this funny bend to it? Have you ever stuck your arm in the pool and noticed that it looks like your arm's broke because it goes at a different angle? Well, there's a reason why that happens. Light bends, light rays coming from this light right here, they move at a certain speed. And when they hit something other than air, they change speeds and it makes them bend. Okay. So when light hits this bottle, when light hits it as it starts traveling through, the light is bent. And that's why when you look through things look like they're distorted because the light is bent. Well, if you'll look at this picture right here, this is actually very correct. What you're looking at right here, the orange is light right here. And so what happens is let's say we draw a circle here. Okay. So as light from the circle goes through into this lens right here, if you'll notice, the lens bends the light and it causes it to come out. Okay. And it makes it move like this. It widens it. Okay. And that makes the circle that we just looked at that's on this side, since the light bends out and goes out, it makes that circle look bigger when you look at it through a lens. Okay. I can't draw very well with this stupid computer. But anyway, this picture right here gives you an idea of what I'm talking about. As something goes through, as the light goes through, whatever you're looking at, whether it's a ladybug, ant, or whatever, it looks small right here, but as it travels through the lens bends it and it makes it look bigger. So over here on this side where you look, it looks bigger. Okay. That is how microscopes work. And that's how magnifying glasses work. All right. Let's see here. So one more word, and very important for a microscope to have a good, what is called resolution. And well, wait a minute. I might have blown past it right here. Resolution. No. Curve flat. No. Resolution is over here. Yeah, it's right down here at the bottom of this page. All right, so what is resolution? Okay. Right here is the definition for resolution. Resolution is another term for the sharpness of an image. Hit pause and we'll talk about it. Okay. If you were in my class back before Thanksgiving, my projector was going out and it looked horrible. The resolution was extremely poor. We could hardly read words on it. It was just massively poor. And Mr. Bergeson came in one day and looked at it and he said, that's horrible. We got to get you something. So they got me another projector. They stole it from the cafeteria and they put it in my room. Now we have this beautiful magnification or resolution where you can read every word, and it's like the difference in night and day. I'll never forget. We got a big screen TV, and my wife kept telling me, "You need to get high definition TV from the cable company." And I was like, it ain't worth the extra money. And she kept telling me, "You need to get it. You need to get it. You need to get it." And I wouldn't get it. So one day she went and got it on her own. And when we hooked it up, it looked beautiful. The difference between a low resolution TV and a high definition TV or high resolution TV is remarkable. When you're looking through a microscope, you need to have high resolution. In other words, when you look through that microscope, you want to be able to make out the image. If you can't make out the image, then there's no use in looking through the microscope. Okay. So resolution is how sharp is the image. Okay. I can tell right now the image of me on this little Chromebook computer down here in the corner, this image of me is not very good. The camera that I got at school on the computer at school, the camera that they bought for us teachers, is much nicer. It has a higher resolution rate, and I look better. You can see me a whole lot better in that video than you can with this little webcam thing on this Chromebook right here. All right, that's it. That's the end of the class today. Sorry it's late. I tried to avoid professional developments when I can because I know I need to get you all these videos, but it happens on occasion. So once you get these things typed up, you're good. Make sure you're already late with your chapter 2, section 2, but if you still haven't turned it in, you need to get that thing turned in to me so that you can get half credit for it. I'm Coach Bilotsky. I hope you have a good day, and we will talk to y'all tomorrow. See ya.